Hi everyone, I'm Jesse Lee, and welcome to Physics Mechanics. This course has 9 videos and will cover kinematics, forces, Newton's 3 laws of motion, impulse and momentum, energy, relative motion, projectile motion, circular motion, and spring motion. Before taking this course, it is recommended that you are proficient in geometry or are proficient in Algebra 1 and understand the trigonometric functions sine and cosine. In the description, there will be a link to the list of all videos, and by clicking on that link, you can also access a spreadsheet that shows you the list of content covered in each video. So that will be really helpful if you need to review a certain topic and need to find where it is. But without further ado, let's get right into this video. This video will cover 1D kinematics. Kinematics is the branch of mechanics concerned with the study of motion of objects without reference to the forces that cause those motions. There are 5 important terms related to kinematics. So here are the 5 terms, and they've been placed into 3 groups to make them easier to remember. So there's distance, displacement, speed, velocity, and acceleration. And you've probably heard of some of these terms and may have even thought that some of them mean the same thing and use them interchangeably. However, they all have different meanings, which we're getting into right now. So first, what is the difference between distance and displacement? Distance is the amount of ground covered by an object during its motion. So it doesn't matter the direction that an object is traveling. All that matters is how much it travels. Displacement is the length from the starting point of an object to its finish point. So now that you know what these 2 terms mean, check your understanding. If you walk 5 meters forward and 5 meters backward, what are the distance and displacement? The solution will come in 3, 2, 1. So your distance is 10 meters because distance doesn't care about the direction that you're walking in. All that matters is that you walk 5 meters and then you walk another 5 meters. So you've walked a total of 10 meters. And displacement, well, you walked 5 forward and 5 backwards. So you ended up in the same place that you started in. So therefore your displacement is 0. So now speed versus velocity. So speed is distance over time, and velocity is displacement over time. And since displacement cares about direction, velocity has a direction and a value, whereas speed only has a value because distance doesn't care about direction. So that also means that it's possible for velocity to be negative. So if you say that going right is positive, then if you're moving leftward, then your velocity is negative. And this is something that we'll get more into in the next video. But in this video, we will see some problems with negative velocities. So then there's acceleration. Acceleration is the rate at which velocity is increasing. So if you had an acceleration of, say, 10 meters per second squared, that means that every second, your velocity is increasing by 10 meters per second. So if you started with a velocity of 0, then after 1 second, your velocity is 10 meters per second. After 1.5 seconds, your velocity is 15 meters per second. And it's possible to have a negative acceleration, which means that velocity is decreasing. So for example, if you had an initial velocity of 50 meters per second and an acceleration of -5 meters per second squared, then after 1 second, you'd have a velocity of 45 meters per second. After 2 seconds, a velocity of 40 meters per second. And eventually, you're going to be having a negative velocity, which means that you're going in the other direction. And the acceleration due to gravity on Earth is 9.8 meters per second squared. So that's a pretty important fact that you should keep in mind because you're going to be using it for the upcoming problems. For the rest of this video and this course, we're mostly going to be using displacement, velocity, and acceleration, However, it's still useful to know about distance and speed because you use them in your everyday life. For example, when you're driving. The next topic that we're getting into is displacement, velocity, or acceleration versus time graphs. Displacement, velocity, or acceleration versus time graphs match each point in time with the displacement, velocity, or acceleration of an object. So here's an example of a displacement versus time graph. And to check your understanding, what is the displacement of the object at time t equals 4? The solution will come in 3, 2, 1. So the answer is 8 because according to the graph, when x equals 4, y is equal to 8. So you can usually determine information about the other two graphs by having just one graph. So first, we have slope at a point. So the slope at a point of the displacement graph is velocity, and the slope at a point of the velocity graph is acceleration. So we have the same graph here. So to check your understanding, what is the velocity of the object at time t equals 7? The solution will come in 3, 2, 1. So according to the graph, the line at time t equals 7 has a slope of 1/2. So therefore the velocity is 1/2. So area under the curve can also be used to determine information about the other graphs. So the area under the curve of the velocity graph is displacement, and the area under the curve of the acceleration graph is velocity. So now we have the same graph, except this time it's a velocity versus time graph. So to check your understanding, what is the displacement of the object from t equals 5 to t equals 10? The solution will come in 3, 2, 1. So we just determined area under the curve between x equals 5 and x equals 10. So we have a trapezoid, and we use the formula for the area of a trapezoid, and we get 36.25. So the displacement of the object from t equals 5 to t equals 10 is 36.25. So now suppose that the graph is an acceleration versus time graph. If the velocity of the object is 0 at t equals 3, what is the velocity at t equals 7? The solution will come in 3, 2, 1. So this is still an area under the curve problem, except with different bounds. So this time we have two trapezoids. So using the formula for the area of a trapezoid, we get the area is 29. So the velocity of the object at t equals 7 is 29. And suppose that we didn't know the velocity of the object is 0 at t equals 3. So if we suppose that the velocity of the object is x at t equals 3, then at t equals 7, the velocity is 29 plus x. We're about to get into the most important topic of this video, the kinematic equations. These allow us to use given kinematic information to solve for unknown kinematic information. The reason why this is the most important topic is because it will continue to be used a lot in future videos. Before we get into the kinematic equations, first you need to know what the variables in the kinematic equations represent. So first we have A represents acceleration and T represents time. These are pretty easy to remember. A triangle called delta represents change. So delta x represents change in position. Technically it represents change in x, but since we're only dealing with 1D kinematics in this video, the change in x is the change in position. And you know that change in position is also known as displacement. Some people use d for displacement, but we're going to be using delta x. An overline represents average. So overline v represents average velocity. V subscript f represents final velocity, and V subscript I represents initial velocity. So now here are the 5 kinematic equations. And it might seem a little scary to remember, but it makes it a lot easier to remember if you know why they're true. So I'll go over them one by one. So the first one's pretty simple. I already told you that velocity is displacement over time. And if you just rearrange it, you're going to get displacement equals velocity times time. Average velocity is equal to final velocity plus initial velocity over 2. So you know that to get an average, you just add a number of values up and then divide by the number of values. So that's basically what this is doing. And keep in mind that you need to assume that acceleration is constant, which we're going to be assuming throughout this entire course. The third equation is acceleration equals Vf minus Vi over t. So you already know that acceleration is how much velocity changes in a given amount of time. So the numerator, Vf minus Vi, is just the change in velocity, and the denominator is time. Delta x equals 1/2 at squared plus Vit. So this one can be proved using the first 3 kinematic equations. So we start off with the first 3 kinematic equations, and we plug in the value for the average velocity from the second equation into the first. So we get this. And now from the third kinematic equation, if you isolate Vf, you're going to get that it's equal to At plus Vi. So now you can plug that in for Vf. And now if you simplify, you're going to get the fourth kinematic equation. So the fifth one, the proof for that is a little longer, so we're not going to go over it. So this one is the one that you kind of just have to remember. If you can't remember it, that's fine, but remembering it generally makes it more convenient. Now that you've learned about the 5 kinematic equations, here are 6 practice problems. For the first 2, I will tell you which kinematic equation to use. For the next 2, the 5 kinematic equations will be listed, but I won't tell you which one to use. The last 2 are for you to solve without looking at the kinematic equations. Remember to pause after each problem if you need more time. Here's problem number 1. The solution will come in 3, 2, 1. So the first thing that you need to ask yourself when solving a problem is, what are you trying to solve for? And it's clear that you're trying to solve for the acceleration. So now we plug in all the values that we know. We know that Vf is 15, Vi is 5, and t is 5. So plugging those in, you're going to get that the acceleration is 2 meters per second squared. Here's problem number 2. The solution will come in 3, 2, 1. All right, so we're trying to solve for the height of the ball when it reaches its peak, which is basically delta x. And we know that the initial velocity is 10 meters per second. The problem tells us that. And the acceleration is negative 9.8 meters per second squared. So it's negative because we decided that upwards is positive since we decided that the initial velocity is 10. So since the acceleration is downwards, it needs to be negative. And when the ball reaches its peak, its velocity is 0, because after it reaches 0, it's going to start becoming negative. So it's going to start going downwards. So therefore, we know that Vf is 0. So now plugging in all the values that we know and solving for delta x, we're going to get delta x is 5.1 meters. Here's problem number 3. The solution will come in 3, 2, 1. So as always, first thing we ask ourselves is, what are we trying to solve for? And in this case, it's displacement. And since we don't know which kinematic equation to use, we must ask ourselves, what information do we already know? We already know the initial velocity, the time, and the acceleration. So we must find a kinematic equation that has only one variable that we do not know the value of. And conveniently enough, it's the fourth one. It's convenient because the variable that we do not know is displacement, which is what we're trying to solve for. So Since the problem's asking how much has the ball dropped, we can say that going downwards is positive. So therefore we can make the acceleration positive, and plugging in all the values, we're going to get that the displacement is 19.6 meters. Here's problem number 4. The solution will come in 3, 2, 1. So we're trying to solve for displacement, and the information that we already know is the initial velocity, the final velocity, and the time. So in this case, we can use either the second or the third kinematic equation, but the second one is easier because if you use the third one, you're going to solve for acceleration, and that only makes it more complicated. So using the second kinematic equation, we'll get that the average velocity is 5 meters per second, and we haven't solved for displacement yet. So now we need to use the first kinematic equation. So the displacement is 5 times 2, and that is 10 meters. Here's problem number 5. The solution will come in 3, 2, 1. So we're trying to solve for t, and we know the initial velocity, the final velocity, and the displacement. So we can use the fifth kinematic equation. So 80 meters per second squared and equals 0 meters per second squared plus 2a times 1,200 meters. So using this, we solve that the acceleration is 2.67 meters per second squared. And plugging that in to the third kinematic equation, we can solve for time. So time is 30 seconds. Here's problem number 6. The solution will come in 3, 2, 1. So the hint tells us that the final velocity is equal to the initial velocity times -1. So that allows us to use the third kinematic equation since we know the final velocity, initial velocity, and time, or sorry, acceleration. So we're trying to solve for time, and we decide that downwards is negative. So we solve to get that t equals 4.08 seconds. And if you did not know the hint, you could still solve this by using the fourth kinematic equation, but that's more complicated since you'd have a quadratic. So here are the topics that were covered in this video, and that's it. We're done. So I hope this video was super helpful. If you aren't that confident with the 5 kinematic equations, don't worry because we will continue to practice them in the future, and eventually you'll be able to master them. A good learning habit is to make a schedule of when you will watch each video. It's fine if that schedule changes because something gets in the way, but making a schedule will help produce the best learning outcome. If you want, you can check out my channel. I have other courses that may be helpful to you, and also subscribe so you won't miss future courses. Keep in mind that I do not recommend learning more than one course at a time in order to ensure the best learning outcome. Thanks for watching. I'll see you in video number 2.